All right, welcome to day 7. Let's go see what our problem is. Giant whale has decided your submarine is the next meal. It's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs eat its own tiny submarine. Seems in to rescue you. They seem preparing to blast a hole. Sensors indicate a massive underground cave system just beyond where they're aiming. Crab submarines need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. It doesn't like they'll be aligned. Maybe you can help. There's one major catch. Crab submarines only move horizontally. Quickly make a list of the horizontal position of each crab. Puzzle input. Crab submarines eliminate fuel. Finally, make all their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. This means there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them on, but the cost of least fuel is horizontal position 2. Move from 16 to 2, blah, blah, blah. This costs 37. This is as possible. Can determine the horizontal position that crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Okay, so as a math person, I know how to solve this problem. And the way you solve this problem is by choosing the median. Why do you choose the median? So the median is the number such that half are on one side and half are on the other side, right? And so let's say I have something at the median and I move to the right by 1. Then everybody on to the right of me, which is half the people, has to go 1 fewer step. So, but everybody to the left of me, which is also half the people, have to go 1 more step. So it doesn't change. And then at some point you like cross over and you pass somebody, right? And once you pass that person, then you're actually forcing him to move when he didn't have to move before. And everyone to his left is still having to anyway. So the median is right, I think. So like, did that again. Hold on. So like if I copy this and go into IPython and say positions equals this, and then if I sort them, positions, so there's 10 of them, right? So if I do positions, so if I do 4, and if I do positions, 5, either one can be a median, and it's going to be 2 no matter what, and so that's fine. So if I do like sum of abs p minus 2 for p in positions, I get 37, right? But if I were to change that to 3, it would go up to 39. If I were to change it to 1, it would go up to 41. So I want to use the median. Anyway, that's the moral of the story. And how much fuel must they spend to align to that position? And so the other trick is that, if you have an even number of things, the median is like halfway between the two of them. But you can't really do that because these have to be, well, actually, I'm trying to think if I can be like halfway between. Let me just look at the puzzle input and see. So sort P's 499, P's 500. So they're equal, so it doesn't really matter. So they help me out here. So that's going to be the answer, but I haven't written any code. Let's write some code because why not? and what you'll see is that if I do, if I go to 320, you can see it went up, and if I go to 322, that went down. So that means that I'm wrong. Okay, so never mind. My whole median thing is wrong. So after that speech, let me well, whatever. We'll just brute force it. All right. How about that? So let's just brute force it. I don't know why I got it wrong, but I got it wrong, I think. So let's see what happens. Raw equals this. Positions equals that. Okay. And def total distance to n, which is an int, and it's going to return positions, which is a list of ints, and target. That's a better name. Okay, let's see. Like, I feel like in part 2 they're going to make me regret brute forcing it, but that's all right. Return sum abs x minus target. Okay, that's good. And def best position. So that's smart. The question is, might I want to move to something that is actually, let's say low equals min positions, high equals max positions. Return min of range low, high plus 1, key equals lambda x total distance to positions. Yes. Okay, and then assert total distance to, or let me do this and say BP equals best position positions. Assert that BP equals 2, and then TD equals total distance to positions, comma BP, and assert that TD equals 37. Let's check that out. And I'm curious why my median thing is wrong, but whatever. Extra parentheses. Copilot should have caught that for me. Okay, so that works. If name equals main. This will be a little bit slow because it's like 1,000 times 1,000, but that's all right. Okay, so let us go back to this guy. And so raw equals open data day 07 dot text dot read. That's right. BP equals that. TD equals total distance to. Print best position BP. Print total distance TD. Seems good. Why is this underlined? Did I get an extra thing in there? Okay, good. All right, so let's run it. 321. Interesting. So why? Because I didn't do the absolute value. God, I'm stupid. Okay, so I was right with the median. I forgot to do the absolute value. Um, that was not what I wanted to do either. Today is not my day. Conda activate Advent 2021. See Advent 2021. Let's see if it remembers my thing. Boy, I'm stupid. I knew I was right about this thing. I forgot to do the absolute value. Um, that went up. That went up. Okay. So anyway, dumb, 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 dumb. But there's the total distance, and God, that was stupid. All right. Continue part 2. Crabs don't seem interested. Perhaps you missed it. Crab submarine engines burn fuel at a constant rate. Instead, each change of one step costs 1 more unit fuel than the last. The first step costs 1. Second step costs 2. The third step costs 3. As each crab moves any further, this changes. This becomes 5. Move from 16 to 5 is 66 fuel. This costs a total of 168 fuel. It's now the cheapest possible outcome. Turn in the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Okay. First step costs 1, second step costs 2. Okay, so let us go and do def cost. So it turns out the median wouldn't have helped for this anyway. So int goes to int. Okay, here we go. Watch this. The first step costs 1. The second. This is going to be the real test of Copilot. The second step costs 2. The third step costs 3, and so on. Oh, come on. Cost 2 in addition, cost 2 additional. Third step costs 3 additional, and so on. Copilot, you're really letting me down. Okay, and so now the thing we know is that uses the well-known fact that that 1 plus 2 plus n equals n times n plus 1. I have to, once I tell it to use that math formula, then it knows to use that math formula. But so let us say 16 to 5 is 66 fuel. That feels weird to me. So assert that cost of 9 equals 45 seems